Hi, this is Adrian calling in from Live to Learn Academy. Today's lesson we'll be going over lesson 2.3, exploring the instantaneous rate of change using graphs. So this is to piggyback off of our lesson back in 2.2, and we're just going to do a couple of questions just to understand the concept fully. So let's look at instantaneous rate of change. So let's say I have a graph over here, and let's say this graph is a parabola, okay? I have a graph, it's a parabola, and let's say I want the instantaneous rate of change at the point 2. So that means I want the tangent, I want to find the slope of the tangent. So what is the slope of this guy at 2? So the way we approximate this instantaneous rate of change is we use secants, or the average rate of change, to approximate the instantaneous rate of change. So for example, if I take a point at, let's say, 4, and I draw the tangent of this line, and then let's say I take another point at 3, and I take the tangent of this line. That was a bad line. Let's say I take the tangent of this line. So I got the tangent at 4, I got the tangent at 3. And now let's say I take another point, let's say 2.5. I take the tangent of this guy. So as you can tell, as I take a point, the tangent at a point closer and closer and closer to 2, what ends up happening? These lines, these tangent lines, so this blue line, this green line, and then this pink line, they are slowly getting closer and closer and closer to my ideal line, which is the red line. So notice how as we go from the tangent at 4 to the tangent at 3 to the tangent at 2.5 to the tangent at 2, we are slowly getting closer and closer to approximating what is the actual tangent at 2. What is the instantaneous rate of change at 2? So this is how you got to think of it when it comes to graphs, right? Every point closer to this x value of 2, we are getting closer and closer and closer to that instantaneous rate of change. So let's see how this looks in a question. So I want to give you guys an example, okay? Let's do an example. Let's say the function is 3x squared plus 2x minus 1. And we want to find the tangent at x equals 2. So one way we can really do this is we can find the slope at a point after 2 and a point before 2. So let's look at a point, we're going to find 1.9 and 2.1. So remember from the last lesson, this is called a centered interval. Okay, we're doing a centered interval method. So what we're going to do is we're going to say f at 2.1 minus f at 1.9 over 2.1 minus 1.9. So we know 2.1 minus 1.9 is 0.2. But now we got to find f at 2.1. F at 2.1 is just going to be 2.1 squared plus 2 times 2.1 minus 1. We plug that into our calculator. So you get 16.43. And then if we take f at 1.9, you end up with 13.63. So if I take these numbers and I put them over here, putting them back into my original equation, 16.43 minus 13.63, so 16.4 answer divided by the 0.2, I end up getting 14. So this 14 actually is the slope at 2. So I want you guys to take that in. This right here is the slope at x equals 2. Okay, so that's what we did using the centered interval method. Now, we may be able to do this at many different points. Remember, we can do the centered interval method, we can do the preceding interval, we can do the following interval. It really depends on which question your teacher wants you to do. So, in short, guys, when we're looking at instantaneous rate of change, there's two ways we want to think of it. One way is obviously the interval method that we did in the past. So centered interval, preceding interval, and following interval. But the other way is to actually look at what's happening with the slopes. If I take a slope and I get closer and closer and closer to that slope that I actually want, then I will have the ideal slope or the ideal average rate of change. And look at it like this. If I want this kind of slope, let's say this is what I want. How do I get there? I may have to take a slope like this, and then a slope like this, and then a slope like this, and then a slope like this. And as I keep coming, I slowly finally get to this slope. So look at how many slopes that I had to go through in order to get to the ideal slope. So as I started approaching, I ended up getting to the ideal slope that I want. And that's the main point of this lesson. It's really just a piggyback off of the last lesson. So if this made sense to you, feel free to drop a thumbs up, like and subscribe to the channel for more videos like this. And if you are somebody who needs tutoring, feel free to go to the link in our description. It'll take you directly to our website where our team can get in touch with you and get you set up with tutoring. But without further ado, I'll see you guys in the next video.